This is lesson number 3-8. We're going to begin with the warm-up now. Problem number 1. Y equals negative 5x and y equals 2x plus 14. The first thing I want to do is figure out which equation has a variable all by itself. In this situation, both equations actually have y by itself. So I'm going to go ahead and just use the top equation. So in the first equation here, since y is by itself, I'm going to circle what y equals, which is negative 5x. Then I'm going to show that I can replace the y in the second equation with negative 5x since they are the exact same thing. So now I have negative 5x equals 2x plus 14. Now I'm just going to solve for x. So I'm going to subtract 2x from both sides. I get negative 7x equals 14. Divide both sides by negative 7. X equals negative 2. So now I know in our ordered pair, my x value is negative 2. Now I want to find out what y is. And to do this, I just take negative 2 and I can plug it back in for x either in the first equation or the second equation. I'll get the same either way. If I plug it into the first equation, I get y equals negative 5 times 2. So y equals negative 10. So my y value is negative 10. So the point these two equations have in common, the point where they were to cross if we were to graph them, is the point negative 2, negative 10. If I were to plug negative 2 into the second equation, I would have had 2 times negative 2, which is negative 4. And then negative 4 plus 14 is positive 10. And I just found my mistake right there by going in and checking it. So hopefully you guys saw it as well, that this actually should be a positive 10. Because I forgot to multiply by a negative 2 down here. Negative 5 times a negative 2 is a positive 10. So y is positive 10. Now in number 2, I can see that in the first equation, I have x all by itself right here. So I'm going to circle what x equals. And then I'm going to substitute what x is, which is 2y subtract 8, and for this x in the second equation. So now I have 2y plus 2 parenthesis 2y subtract 8, close the parenthesis, equals 2. Now we want to distribute this 2 through. So we have 2y plus 4y subtract 16 equals 2. Now we're going to combine like terms. 2y plus 4y is 6y, subtract 16 equals 2. Now we're going to add 16 to both sides, and we get 6y equals 18. Divide both sides by 6, and we now know that y equals 3. So in the point, in my ordered pair, I know that my y value is 3. Now I need to find my x value. So I'm going to take 3 and plug it back in up here. The easiest one to do would be the one up here at the top. And we have, when I do that, I get 2 times 3 subtract 8 equals x. So we get 6 subtract 8 equals x. So negative 2 equals x. So we know our x value is negative 2. So the point these two have in common, the point where they would cross if they were graphed, is negative 2, 3. In problem number 3, the best way to solve this one is to use elimination. We have a 2x in the first equation and a negative 2x in the second equation. So if we just add these two together, we have 2x plus a negative 2x, which is 0. Negative 3y minus y, or we could say negative 3y plus a negative y, gives me a negative 4y equals 4 plus 4 is 8. So now we're going to divide both sides by negative 4. So y equals negative 2. So now I know that the y value and the point they have in common is -2. Now I want to find my x value. I'm going to go ahead and just use the first equation and plug it back in. So I have 2x subtract 3 times -2 equals 4. Now it doesn't matter which equation I plug it back into, I'll get the same answer. But I just chose to do the first one. 2x plus 6 equals 4. Subtract 6 from both sides, and I get 2x equals -2. Divide both sides by 2. X equals -1. So I know my x value and the point is -1. So the point that these two have in common, if they were to be graphed, where they would cross, is -1, -2. Okay, for number 4, once again, since I have a 3y and a -3y, the easiest way to solve this one would be to go ahead and to add them together. So we have x plus x is 2x. 3y plus a -3y is 0, equals 9 plus a -3, which is 6. Divide both sides by 2, x equals 3. So we know that the x value in our ordered pair is 3. Now I'm going to plug 3 back in. I'm going to go ahead and just do it to the top one. So if x is 3, I have 3 plus 3y equals 9. I'm going to subtract 3 from both sides. So I get 3y equals 6. Divide both sides by 3, and y equals 2. So the point that these two equations have in common is 3, 2. And that's the point that they would cross if we were to graph this. Okay, and the last one here in the warm-up says that we need to define the variables, write a system of equation, then solve using elimination. So we're going to go ahead and define our variables. I'm going to go ahead and use x and y. I'm going to say that x is the first number, and that y is the second number. Then, to write my system of equations, I have twice one number, so twice one number added to another number equals 18. Then 4 times that first number, which is x, so 4 times x, let's see, I didn't read it before I did that. So 4 times the first number minus the second number, so minus 2y equals 12. Oh, I am totally messing up on this. Let's erase that right here. Sorry about that, guys. Hopefully you guys saw my mistake there. This is 4 times the first number minus the second number, not 2 times the second number, just minus the second number, which is y, equals 12. Okay, now I have it set up really nicely where I can just add it together and eliminate my y's. So I'm going to add these two together. I get 2x plus 4x is 6x. Y plus a negative y is 0, equals 18 plus 12 is 30. If I divide both sides by 6, I get x equals 5. So I know that my first number is 5. So I'm going to write that over here. That my first number equals 5. Now we want to find the second number. Now that I know the first number equals 5, go ahead and erase this so I have room to work. I'm going to go ahead now and plug 5 in for x. I'm going to go ahead and do it to the top one. 2 times x, which is 5, plus y equals 18. So 2 times 5 is 10, plus y equals 18. Subtract 10 from both sides, and we get y equals 8. So now we know that our second number is 8. So there's the answer to our system there. And since there is one solution, it's going to be consistent and independent. Okay, now for the lesson. We are going to solve each system of equations using elimination. Now, in the past, it's already been set up for you when I add them together, one of the variables is going to eliminate. But if you look at number 1 here, you can see that's not the case. Negative 2x plus x gives me just negative x. Y plus 4y equals 5y. So when I add these together, none of my variables eliminate. So I have to multiply either the top equation by something or the bottom equation by something, so then when I add them together, that one of the variables will eliminate. So I'm going to go ahead and start with the x's. If I wanted to eliminate the x's, I can see here that I have a negative 2x. So it would be really convenient if this was a positive 2x, right down there in the second equation. So what I need to do is I'm going to multiply the second equation by a 2 so that I do have a 2x there. So, but when I multiply the bottom, I have to multiply everything by 2. So I'm going to rewrite the top equation over here. Negative 2x plus y equals 3. That stays the same. But now I have to multiply everything through by 2. So 2 times x is 2x. 2 times 4y is now 8y equals, and 2 times 3 is 6. Now, when I add these two together, my x's will eliminate. I have negative 2x plus 2x, which is 0. 1y plus 8y gives me 9y equals 3 plus 6 is 9. Divide both sides by 9, and y equals a positive 1. So now I know that in my ordered pair, my y value is 1. Now we just do the exact same thing we did before, though. I'm going to take 1 and plug it back in either to the top or bottom equation and solve for x. I'm partial to doing it to the top, so I'm just going to go ahead and do it to that one. So I have negative 2x plus y, which is now 1, equals 3. Subtract 1 from both sides, so I get negative 2x equals 2. Divide both sides by negative 2, x equals negative 1. So now I know that the point these two have in common is negative 1, 1. That's the point where if I was to graph these two equations, they would cross. Since there's one solution, we're going to label this as consistent and independent. Now, if you'll notice, there's a big or there in the middle of your paper, and on the right-hand side, it has the exact same problem again. So what we're going to do is show that there's another way to do this. And on the first example, I multiplied the bottom by 2 to eliminate the x's. But I'm going to do this again, and instead this time, I am going to multiply the top by negative 4 so I can eliminate the y's first. Okay, so we're going to multiply the top by a negative 4. So I have a negative 4 times a negative 2x is a positive 8x. Negative 4 times y is negative 4y equals negative 4 times 3 is negative 12. Then the bottom is just the same, x plus 4y equals 3. Now we're going to go ahead and add these together because now my y's are going to eliminate. I have 8x plus 1x gives me 9x. And negative 4y plus 4y is 0 equals negative 12 plus 3 is negative 9. Divide both sides by 9. And x equals negative 1, which is the same answer we got before, where our x value is negative 1. Now we're just going to plug negative 1 in for x. Top or bottom, doesn't matter. I'm going to go ahead and do it to the top. So I have a negative 2 times x, which is negative 1, plus y equals 3. So now I have 2 plus y equals 3. Subtract 2 from both sides, and y equals 1, which is the exact answer we got before, negative 1, 1. So, does it matter if you which one you try to eliminate first, which variable? No. So, I could have multiplied the top by negative 4 or the bottom by positive 2. I still get the same answer. My whole goal is to get where we have opposite integers for one of the variables, so when I add them together, they go to 0. Okay, this is number 2. Now, once again, you notice if I was to add these together, that none of the variables would eliminate. But I do notice that I have a 2x and a 2x. It'd be very convenient if the top was a negative 2x and the bottom was a positive 2x, or vice versa. It doesn't matter. So I'm going to multiply the top by negative 1. You could choose to multiply the bottom by negative 1. It would not change the outcome. You get the same answer either way. But I'm just going to do the top one by negative 1. So we have a negative 1 times 2x, which is negative 2x. Negative 1 times the negative 3y is a positive 3y, equals negative 1 times 4 is negative 4. The bottom stays the same. Now I'm going to add them together. And I have negative 2x plus 2x, which is 0. 3y plus y, which is 4y, equals negative 4 plus a negative 4 is a negative 8. Now I'm going to divide both sides by 4. So y equals negative 2. So I know that in my ordered pair, my y value is negative 2. Now I'm going to take negative 2 and plug it back in and solve for x. I'm going to go ahead and put it back into the top one. So I have 2x minus 3 times negative 2 equals 4. So 2x plus 6 equals 4. I'm now going to subtract 6 from both sides. So 2x equals negative 2. Divide both sides by 2 and x equals negative 1. So the point that these two equations have in common is negative 1, negative 2. Since there's one solution, I'm going to label it consistent and independent. Now that's one way to solve it. Now we're going to do it another way. This time I want to eliminate my y's. So think, what would you multiply by so that my y's eliminate? Well, I have a negative 3y in my top equation and a positive 1y in the bottom equation. It'd be very convenient if I have a negative 3y in the top and a positive 3y in the bottom. So I'm going to go ahead and multiply the bottom by a positive 3. So I'm just going to write the top again over here. So 2x minus 3y equals 4. On the bottom now, I'm going to have 3 times 2x, which is 6x. 3 times y is a positive 3y, equals 3 times negative 4 is a negative 12. Now I'm going to add these together. 2x plus 6x is 8x. Negative 3y plus 3y is 0, equals 4 plus a negative 12 is a negative 8. Divide both sides by 8 and x equals negative 1. So I know the x value in my point is negative 1, which is what I got on the previous example. Okay, now I'm going to take negative 1, plug it back in. I'm going to go ahead and do that to the top. So I have 2 times negative 1, subtract 3y equals 4. 2 times negative 1 is negative 2 minus 3y equals 4. We're going to add 2 to both sides. So negative 3y equals 6. Divide both sides by a negative 3. Let me see if this one, there we go. And I get that y equals negative 2, which is the same answer I got in the previous problem. So the point they have in common, the point where they would cross if I was to graph them, is negative 1, negative 2. Okay, on number 3, think about what you'd like to multiply what by to eliminate which variable. We have two options here. There's actually lots of options. I can multiply the top by a negative 3. I think that's going to be our best option right now. If I multiply the top by negative 3, then I'd have a negative 6x in the top and a positive 6x in the bottom. Let's go ahead and do that. Oops. So on the top, I have a negative 6x plus 9y equals negative 18. Now you want to rewrite this below That way you're going to avoid mistakes. It may seem kind of unnecessary, but rewriting these two equations helps you to avoid making mistakes. So now we have 6x minus 9y equals 9. When I add them together, I get a negative 6x plus 6x, which is 0. I get a 9y plus a negative 9y, which is 0, equals negative 18 plus 9, which is negative 9. So I have 0 equals negative 9, which we all know is a false statement. Therefore, our answer is no solution. Okay, here's number 4. And once again, you need to think about what's going to be the easiest thing to multiply by. And I can see that I have a positive 4y in the first equation and a negative 1y in the second equation. So I think it'd be easiest to multiply the bottom equation by a positive 4, so that I would have a positive 4y in the first equation and a negative 4y in the second equation. So I'm going to go ahead and do that. So we're going to rewrite the top one again. So on the bottom I have 4 times 2x, which is 8x. Then I have a negative 4y equals, and then 4 times negative 3 is negative 12. Now we're going to add them together. I have a negative 5x plus 8x, which is 3x. I have 4y plus a negative 4y, which is 0, equals 3 plus a negative 12 is negative 9. Okay, now I'm just going to solve for x. I'm going to divide both sides by 3. And x equals negative 3. So I know the x value, my ordered pair, is negative 3. Now I'm just going to plug negative 3 back in. I'll go ahead and just do it to the top because that's what I've been doing the whole time. Negative 5 times a negative 3 plus 4y equals 3. So I have 15 plus 4y equals 3. We're going to subtract 15 from both sides. So I get 4y equals negative 12. Divide both sides by 4. And y equals negative 3. So my y value is also negative 3. So the point these two have in common is negative 3, negative 3. That's the point that they would both cross if they were to be graphed. Okay, here's number 5. Now think about, what would you like to multiply by? What would be the most convenient to multiply by here? We actually have two options. I can multiply the bottom by a positive 4 to eliminate my x's. That would give me a negative 4x and a positive 4x. Or I could also multiply the bottom by a positive 12, because that would give me a 12x minus 3y. Either way, it just depends on what you think is the easiest. I'm going to go ahead and just do 4 on the bottom. Rewrite these two equations. So negative 4x plus 3y equals 10. Now 4 times x is 4x minus. Now 4 times a negative 1/4 is just 1y. Equals, and 4 times a half is 2. Now we can add them together. So now I have a negative 4x plus 4x, which is 0. 3y plus a negative 1y, which is 2y, equals 10 plus 2, which is 12. Divide both sides by 2, and y equals 6. So I know that the y value in our ordered pair is 6. Now we're going to go ahead and plug it back in. Go ahead and just go at the top again. So negative 4x plus 3 times 6 equals 10. Negative 4x plus 18 equals 10. Subtract 18 from both sides, and I get negative 4x equals a negative 8. So if I divide both sides by a negative 4, and I don't have room, let me see if I can move this up a little bit. Nope. We're out of room, so I'm just going to divide both sides by negative 4x. Negative 8 divided by negative 4 is a positive 2, so x equals a positive 2. So the point these two have in common is 2 comma 6. Now, how do you really know if you got your answer right? Well, you can always just plug them back into both equations. Let's go ahead and do that on this one. So if I know that my answer is 2 comma 6, I've got negative 4 times 2 plus 3 times 6 equals 10. Well, that's negative 8 plus 18 equals 10. So 10 equals 10. So yes, I know it works for that one. Let's go ahead and do it for the other one. So on your test or on your homework, you can always plug them back in to really verify that you have the right answer. Okay, so I have x, which is 2, minus 1/4 of y, which is 6, equals 1/2. So that gives me 2 subtract 6/4, which is 1 1/2. So 2 take away 1 1/2 is 1/2. So I know I did it right. So just go ahead and just plug that point back in. You can just do that in your calculator really quickly just to verify if you got the right answer. Okay, here's number 6. And hopefully at this point it's going to be easier to see what you're going to multiply by. I'm looking at my y's right now. I have a 1y and a negative 3y, and I'm thinking it'd be really convenient if I had a 3y on the top and a negative 3y on the bottom. So I'm going to go ahead and multiply this top by a 3. That gives me 3 times 3x is 9x, plus 3 times y is 3y, equals 3 times negative 4 is negative 12. Then I'm going to rewrite the bottom one. Now I'm going to add them together. I get 9x minus 9x, which is 0. 3y plus a negative 3y, which is also 0. And then negative 12 plus 12, which is also 0. So I get 0 equals 0. That is a true statement. So my answer is infinite number of solutions. Okay, we're going to go ahead now and end this video, and now we need to start the second video since we've run out of time.